Let's jump right into this explainer. Today, we're looking at a true marvel of engineering survival. We're going to deconstruct how a 130-year-old piece of equipment, affectionately known as the downhole bucket, is still an absolutely irreplaceable tool in the incredibly high-tech modern oil and gas industry.
To really get this, let's set the scene. Think back to the 1890s. This is way before modern mud pumps, before complex fluid circulation systems, or honestly, any of the heavy-duty tech you see on rigs today. How do you actually clear debris out of a well that's thousands of feet deep without a single watt of electricity? Well, cleaning a well back then meant relying on an incredibly elegant, beautifully low-tech solution.
The answer was surprisingly straightforward. Crews would take a long steel tube, attach it to a rope, and drop it deep down into the rock. They'd plunge it right into the wet slurry at the bottom, let it fill up, and then haul the whole thing back to the surface. And then, they'd do it over and over and over again. It was, quite literally, a bucket on a string. And here's the crazy part. 130 years later, drillers are still running them. So what exactly is this tool? It's called a baler. At its core, a baler is just a long cylindrical container with a one-way valve at the bottom, designed to scoop out water, sand, mud, or drilling cuttings. Back in the old cable tool days, it was literally the only way to clear a hole. Today, it's run down on a wire line as a precision well servicing tool. You use it to meticulously clean fill off the bottom, or to do the exact opposite, dropping a perfectly measured slug of sand or cement exactly where you need it.
The mechanics at play here are just beautifully simple. At the bottom of this tube sits that one-way valve, usually just a ball or a hinged dart. When the baler drops into the debris, the upward fluid pressure forces that valve open, so the tube fills up from below. But the instant you pull up, the sheer weight of the load inside slams the valve shut. The tube rises completely full and nothing falls out. There's no motor, no power line. Gravity does the opening, and the load itself does the closing.
If you want an everyday comparison, think of a household turkey baster. It operates exactly like that, just run in reverse and made out of solid steel. You push it down into the liquid, it fills up, and the moment you lift it, whatever is inside stays inside. The absolute elegance of the baler is that it has just one moving part. There is nothing to power, nothing to brake, and really nothing to jam.
Now, you might be wondering why this old-school tool remains absolutely crucial today. Well, over time, producing wells slowly accumulate sand and scale at the bottom. This buildup eventually buries the perforations in the casing, literally choking off the flow of oil. A baler, run on a wire line, pulls that fill out a few gallons at a time, unchoking the well. Plus, because the baler holds a known fixed volume, operators use it to dump a very precise amount of cement or sand right on top of a downhole plug. You know exactly how much material you placed.
But to really understand the tool's main limitation, we have to look at its volume capacity. The math is pretty simple. To find the capacity in gallons, you square the inside diameter, multiply that by the length of the baler in inches, and then multiply the whole thing by 0.0034.
Let's put that into perspective with a real-world example. Take a 2-inch baler that's 20 feet long. You run that formula and you end up with a capacity of only about 3¼ gallons per run. Just think about that for a second. 3 gallons a trip. That means clearing out 50 feet of packed fill takes a tremendous number of runs. The baler is incredibly effective for sure, but it is brutally slow. That's its major limitation. Which brings up a really great question. Why doesn't the load just pour back out? With an open top, no lid, and no electric motor forcibly holding the bottom valve shut, you kind of have to wonder how it manages to trap all that heavy fluid and sand while traveling up, say, 2,000 feet back to the surface.
Here is where the physics are just fantastic. The tool actually uses the very thing you are trying to extract to keep the bottom valve closed. The weight of the contents pressing down is exactly what holds that bottom valve completely shut. This means the heavier the load, the tighter the seal becomes. It's a brilliant self-sealing principle that relies entirely on the load's own weight.
But it's definitely not without its risks. If you get impatient and try to speed up that slow baling process by jamming or burying the baler way too deep into packed sand, the tool sticks. Suddenly your wire line goes slack. And what was supposed to be a routine cleanout just turned into an absolute nightmare.
Getting your baler stuck means you've just created what's called a fishing job. In the industry, a fishing job is pretty much the hardest, most frustrating kind of rig operation. It is the painful, highly expensive process of trying to retrieve stuck or lost equipment from the bottom of a well that's already full of debris. This is exactly why operators are trained to tag the fill gently, take small, patient bites, and never ever jam the baler down into the sand.
So, let's recap the golden rules of the downhole bucket. Gravity fills it, the load's own weight seals it, and you absolutely must only take small bites to avoid getting stuck. The true elegance of the baler is that nothing powers it and nothing can break it. Well, provided you respect the physics and take your time.
Since this incredibly simple bucket on a string still dominates specific tasks in a highly advanced, multi-billion-dollar industry, it leaves us with a fascinating question to wrap up on. What other complex modern engineering challenges are we currently overcomplicating? Challenges that might just need a brilliant 130-year-old solution. Keep that in mind the next time you're trying to solve a tough problem.